Imagine a digital notebook, a very special kind of notebook. This isn't a notebook you keep on your desk or in your backpack. No, this notebook is digital, living on computers. What makes it truly special is that it's not kept in just one single place. Instead, many people can have copies of this exact same notebook, all updated at the same time. This sharing makes it super strong, incredibly reliable, and very hard to cheat. This amazing digital notebook is what we call a blockchain. It's a chain made of blocks, and these blocks hold information. Think of it like a public record book that's very, very hard to mess with. It's a revolutionary new way of keeping track of all sorts of things online, from who owns what to where your food comes from. Now, this special notebook, the blockchain, isn't owned or controlled by one single person or one big company. There's no single boss in charge. Instead, it's shared across a network of many different computers. This idea is called being decentralized. It's like being part of a huge science team where everyone has a copy of the experiment's logbook. If one computer has a problem, or if someone tries to be sneaky and change their copy, it doesn't matter too much. The notebook is still safe and sound on all the other computers in the network. This decentralization makes the information incredibly secure and very trustworthy. It's a big reason why blockchain technology is so cool, so different, and so exciting for the future. Let's talk about permanence. Once something is written down in this digital notebook, in a block on the blockchain, it's extremely difficult to change it or delete it. It's like writing with the most permanent ink you can imagine. But even stronger than that, this amazing feature is called immutability. It means unchangeable. Each new piece of information or each new transaction is locked into a block. And once that block is added to the chain, it's there to stay. This means you can really trust the records you see on a blockchain. You can be confident that they haven't been secretly altered or tampered with. This makes blockchain fantastic for things that absolutely need to be accurate and stay that way forever, like important agreements or tracking valuable items. Because many people can have copies of this blockchain, especially with public blockchains, which we'll talk about later, the information can be very open for everyone to see. This is called transparency. If you have permission, you can look at the records and see what's going on, but here's the really neat part. Even though it can be transparent, it's also incredibly secure. Clever mathematics, a field called cryptography, acts like a super strong secret code. It protects all the information stored on the blockchain. It's like having a public notice board that everyone can read, but it's encased in unbreakable, invisible glass that only lets new verified notices be added. So it's open for people to see, but locked tight against any bad guys trying to make unauthorized changes. This combination of transparency and security is truly powerful. So we know it's a chain of blocks. But what are these blocks exactly? Well, each block is like a digital container, or you can think of it as a single page in our special shared notebook. This page or block holds a list of transactions or pieces of data that have recently occurred. These could be records of digital money being sent from one person to another, or they could be information about products moving through a supply chain, or even digital votes in an election. When a block gets full of new verified information, it's ready to be sealed and prepared for addition to the growing chain. Each block also contains a special identifying code, like a unique serial number, and importantly, it holds a code that links it directly to the block that came before it. Now let's consider the chain part of blockchain. This is where things get really clever. When a new block is filled with all its verified information, it gets securely attached to the end of the previous block. This process creates a continuous chain of blocks, all linked together in the exact order they were created. This linking isn't done with metal chains, of course. It's done using that super strong digital glue we mentioned, cryptography. Each block contains a cryptographic hash, like a digital fingerprint of the block that came before it. This makes the chain incredibly secure. If some sneaky person tried to go back and change an old block, the fingerprints wouldn't match up anymore, and the entire network would immediately know that something fishy was going on. Inside each of these digital blocks are the records themselves, the actual pieces of information being stored. These records are all bundled together. Each block also gets its own unique code, its digital fingerprint, which is called a hash. This hash is a string of letters and numbers, and it's created based on all the information that's packed inside that specific block. If even one tiny piece of information within the block were to be changed, the block's hash would change completely. This makes it super easy for anyone on the network to see if a block has been tampered with. Crucially, the hash of the previous block is also stored in the current block, and this is what forms the unbreakable cryptographic link, creating the strong, secure chain. So, how does a brand new block full of fresh information get added to this ever-growing chain? It's not just one person deciding. Many computers on the blockchain network work together in a collaborative process. They all check and agree that the new information, the transactions, is valid and legitimate. This agreement process is often called mining, especially in cryptocurrencies like Bitcoin, or achieving consensus. It's like a democratic vote among the computers. Once enough of them agree that everything is correct and follows the rules, the new block is officially added to the end of the chain. And then everyone's copy of the blockchain gets updated with this new block. This teamwork is what makes the blockchain strong, keeps the information accurate, and ensures the integrity of the entire system. First up on our tour of blockchain types, we have public blockchains. Think of these as being completely open to everyone in the whole wide world. Absolutely anyone can join the network. Anyone can download the software and become a part of it. Anyone can see the records that are stored on the blockchain because they are, well, public. And importantly, anyone can participate in the process of validating transactions and adding new blocks to the chain. Famous examples you might have heard of, like Bitcoin and Ethereum, are public blockchains. They are truly decentralized with no single point of control. This openness makes them incredibly transparent. However, because so many people are involved in checking everything, they can sometimes be a bit slower than other types. It's like a big public park where everyone is welcome to come and play. Next on our list are private blockchains. These are quite different from their public cousins. Private blockchains are more like an exclusive private club or a members-only organization. You need specific permission to join the network, to view the data, and to participate. Often, a single organization, like a big company, controls the private blockchain, so it's not truly decentralized in the same way a public blockchain is. The controlling organization decides who gets access, who can see the information, and who is allowed to add new blocks. Because fewer people are involved and there's more central control, these private blockchains are often much faster and more efficient. Businesses might use these for their internal records and data management, keeping things secure and controlled within the company walls. It's like a secret treehouse with a special password to get in. Then there are consortium blockchains, which are also sometimes called federated blockchains. These are a bit like a group project or a collaborative effort between several organizations. Instead of one single company controlling the blockchain, like in a private one, or it being open to absolutely everyone, like a public one, a pre-selected group of organizations shares control and responsibility. Imagine several different banks or a group of companies in the same industry needing to share information securely and efficiently. They all have a say in how the blockchain is run. They set the rules together. This type of blockchain is more decentralized than a private blockchain because control is spread out, but it's not as completely open as a public one. It's a great solution for collaboration between specific trusted partners who need a shared, reliable system. Finally, we have hybrid blockchains. As the name cleverly suggests, these types of blockchains try to combine the best features of both public and private blockchains, offering a mix and match approach. Some information on a hybrid blockchain might be kept private and secure, accessible only within a permissioned network, just like a private blockchain. But other information or certain transactions might be made public, or they might interact with a public blockchain for verification or transparency. This offers a lot of flexibility. A company might use a private system for most of its day-to-day operations, but then use a public blockchain to prove the authenticity of certain important documents or products. It's like having a private, members-only room inside a large public library. You get the privacy when you need it, and you can access the openness when you want it. One of the most famous and widely known uses of blockchain technology is for powering cryptocurrencies. You've almost certainly heard of Bitcoin, and maybe others like Ethereum or Litecoin. Well, blockchain is the amazing fundamental technology that allows these digital currencies to exist and function securely. It enables people to send and receive value online often across borders, without needing a traditional bank or financial institution as a middleman. Each transaction, sending or receiving the digital money, is recorded as a secure entry on the blockchain. This makes the process transparent and highly resistant to fraud. It's like having digital cash that's very difficult to counterfeit and can be tracked. Blockchain is also proving to be incredibly handy for keeping track of products as they move from origin to consumer. This is known as supply chain management. Imagine your favorite brand of coffee beans. Blockchain can create a permanent, unchangeable record that tracks those beans from the farm where they were grown to the processing plant, to the shipping company, to the roaster, to the store, and finally, to your kitchen. Each step, each handover can be recorded as a transaction on the blockchain. This helps ensure products are genuine and not counterfeit. It can also show if perishable goods like food or medicine have been stored at the correct temperatures. This makes things much safer and more trustworthy for everyone involved, from the producer to you, the consumer. Some very smart people are exploring how blockchain technology could make voting in elections better, more secure and more transparent. The basic idea is that each individual vote could be recorded as a secure, anonymous transaction on a specially designed blockchain. Because of blockchain's immutability, once a vote is cast and recorded, it would be extremely difficult for anyone to tamper with it or cast multiple votes. It could also make the entire voting process more transparent, allowing for easier and more reliable auditing. While it's still a relatively new idea for national elections, it shows the incredible potential of blockchain to bring trust to important democratic systems. Imagine every vote being securely counted and easily verifiable by the public. So as you can now see, blockchain technology is a pretty significant deal. It's far more than just the engine behind digital money. It represents a fundamentally new way to record, share, and protect information in a secure and transparent manner. This is critically important because it helps to build trust in digital interactions. Whether it's tracking the food we eat, managing our digital identities, ensuring the fairness of votes, or verifying the authenticity of luxury goods, blockchain offers innovative solutions to old problems. It often reduces or removes the need for a single central authority. Instead, it gives power to the network, to the participants. And that, science fans, is precisely why blockchain is already changing our world in so many positive ways.